biomolecules. Carbohydrates, proteins, enzymes, vitamins, nucleic acids are biomolecules. Let us talk about this carbohydrate. The fundamental unit of carbohydrates is CHO. We have the simplest form of carbohydrate, that is glucose, C6H12O6. In fact, C, carbon, hydrogen, then oxygen, CHO. Glucose and fructose, they have the common molecular formula, but glucose is an aldohexose. Ose means sugar. Aldo means the potential function group is aldehyde. So it's called aldo. Hex means 6. A sugar containing 6 carbon atom with potential aldehyde functionality. That's why it's called aldohexose. Similarly, fructose, even though it has the same molecular formula, but structurally it is different because here it has got keto functionality. And as I already suggested, ose is the suffix used for sugar. We have all CHOs are not sugars. In fact, we have got acetic acid. So you have got a C2H4O2. So when we simplify, you have got a CH2O. It doesn't mean it's a sugar, it is acetic acid. So the general formula can be CX and H2O Y times. So that is the simplest way of representing the carbohydrate. Now we have C6H12O5. That is carbohydrate, even though it is different from this. And that is called rhamnose. Then generally they are optically active because they have got chiral carbon atom. So we have polyhydroxyaldehyde. As I already mentioned, optically active means that particular molecule has chiral carbon atom, that is, it will be having some asymmetric carbon atom. Asymmetric carbon atom is a carbon atom attached to different atoms or different groups of atoms, and they are all optically active. It can rotate the plane polarized light either to dextro, right side, or levo, left side, that is clockwise, anti-clockwise. And generally the carbohydrates are polyhydroxy aldehydes or ketones. Aldose means a sugar with potential aldehyde unit. Ketose means a sugar with keto group as the potential function group. Okay. Five carbon sugar can be called pentose. 6 carbon sugar can be called hexose. A 6 carbon with the aldehyde functionality can be called aldohexose. Similarly, if it has keto group, then it can be called ketohexose. For example, we have CXH2O Y times. In fact, this model of writing the notes is called Cornell notes. The key points can be written on the left side and the main points will be available here. So what are the key points we discussed here? Rhamnose, glucose, fructose, optical activity, pentose, hexose, aldose, hexose, aldohexose, ketohexose. So these are all the important terms for which you should know the expressions. And similarly, the main contents of this topic is, this is the topic 3. That is, we'll be discussing about carbohydrate, proteins, enzymes, vitamins, and nucleic acids. So these are biomolecules. At the outset, I am explaining about the carbohydrates here. Okay? Right. and this is the page wise summary. So you can summarize the entire page here. So during the examination, you can run through this very quickly. Okay, so it will be very comfortable for you. Right. Next. Now let us talk about the lactose is a milk sugar. Ose is sugar, lactum means milk. The carbohydrates can also be called saccharide. So based on the number of units of this glucose or the fundamental unit, it can be called monosaccharide, disaccharide, trisaccharide, tetrasaccharide, likewise polysaccharide. These disaccharides and trisaccharides can be called oligosaccharide. Oligo means a few. So when a few units combine together to form di or trisaccharides, then it can be called oligosaccharide. So the carbohydrate can be classified as monosaccharide, oligosaccharide, polysaccharide. Monosaccharide, we have got nearly about 20 numbers of monosaccharides. They have got the examples of glucose, fructose, ribose, etc. And oligosaccharide can be either disaccharide or trisaccharide. Let me talk about this disaccharide, that is sucrose and maltose. Sucrose is nothing but cane sugar. It's a combination of glucose and fructose. And then the polysaccharide examples are cellulose and starch. And it can also be classified in a different way based on the reaction. For example, the sugar can be reducing type and non-reducing type. So reducing type can be identified by using Felling's reagent or Tollens reagent. And non-reducing sugars. Okay, right. So under carbohydrate, we'll be studying about classification, monosaccharide, glucose preparation, glucose structure and the cyclic form of glucose, then fructose structure, disaccharides, polysaccharides, and some importance. Now let me talk about this glucose. Glucose, it is obtained from cane sugar and also from starch. From cane sugar, the cane sugar is nothing but sucrose here, C12H22O11, that is disaccharide. Actually, it's a combination of glucose and fructose. So on hydrolysis in presence of an acid, it gives glucose and fructose. Similarly, from starch, we can obtain the glucose because starch is the polysaccharide of the monosaccharide units, that is C6H12O6. So it can be written as C6H10O5 n times. So when we hydrolyze it, we are able to get n number of C6H12O6, that is glucose unit, at 393 Kelvin under pressure, that is a 2 to 3 atmospheric pressure. Now let us discuss about the structural elucidation of glucose. We have, actually this is the structure of glucose. CHO, CHOH, 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 and finally CH2OH. So here you have got one primary alcohol, that is CH2OH, it is primary alcohol. CHOH secondary, and this is secondary. This also secondary, and this is also secondary. So it means we have one primary alcohol and 4 secondary alcohol groups. So totally 5 hydroxy groups are there, and 1 potential aldehyde group, and there is a change of position also. Okay. Structural elucidation of glucose. Now, based on the molecular weight determination studies, we can arrive at the molecular formula as C6H12O6. We already discussed about this empirical formula, and the empirical formula can be obtained by the percentage of elements like C percentage, hydrogen percentage, oxygen percentage. Based on that, we can arrive at the empirical formula, and based on the empirical formula, we can get the molecular formula. Now, it is a straight chain of carbon atoms. How it was proved? When glucose is subjected to a reaction with the hydrogen iodide on heating, we are able to get N-hexane. You can write down the structure of N-hexane, which is nothing but CH3, CH2, 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 that is CH2 4 times, then CH3. It means N-hexane. So it is a straight chain, and therefore the glucose should have, that is, a straight chain carbon atom with 6 carbon atoms. And there is a presence of carbonyl group. How it was confirmed? When we take this glucose and when it is treated with the hydroxylamine, NH2OH is called hydroxylamine. OH is hydroxyl group, NH2 amine, so it's called hydroxylamine. Usually this hydroxylamine reacts with carbonyl compound to give oxime. It can react with aldehyde to give aldoxime. It can react with the ketone to give ketoxime. So here we are able to get this aldoxime, CH double bond O. So this OH and this O, they combine, H combine to form water. The water is eliminated. That is called condensation. What do you mean by condensation? A reaction accompanied by the release of neutral molecules like water, ammonia, etc. They can be called condensation reaction. So it forms an oxime. So CH double bond NOH. So from this, it is obvious that the glucose unit has some aldehyde group. And then, now let us proceed. This cyanohydrin formation was obtained here. In fact, you have got the glucose when it is treated with the hydrogen cyanide. So it forms cyanohydrin. So usually aldehydes give cyanohydrin. So it further confirms that it has the potential aldehyde group by the formation of cyanohydrin. Cyanohydrin means any carbon atom bearing hydroxyl group and also cyanide group can be called cyanohydrin. And then on bromination study means we have to pass through this bromine water, and it acts as a mild oxidizing agent so that you are able to get acid, that is gluconic acid. And from this it's clear that is on oxidation it gives acid, means it should have aldehyde group, because aldehyde on oxidation gives acid. And what kind of acid it is? It is gluconic acid. Then the presence of 5 carbon atoms were further confirmed by studying the acetylation reaction. It's called acetylation study. For acetylation, we can use acetic anhydride, that is CH3CO twice O. So by treating glucose with the 5 moles of acetic anhydride, we are able to get this penta-O acetyl derivative. So this OH that reacts and forms an ester with this. So it means we are able to get penta O. O means through oxygen this acetyl derivative is formed. So that is why it's called penta O acetyl derivative. Okay, that is this OH and this COO. So you are able to get COOCH3. Okay, and then we have this, for example, RCH2O, an alcohol. You have got acetyl chloride. So what happens here? That is this RCH2O, and this forms an HCl, so that you are able to get RCH2O COCH3. It's an acetyl derivative. Are you able to follow? And instead of using CH3O COCl, this is acetyl chloride or ethanol chloride, we can use acetic anhydride also. It will result the same product. So we are able to get the acetyl derivative. Are you able to follow? Clear? For any alcohol. So since it has only one alcohol, we are able to get acetyl derivative. But here got 5 hydroxyl group, and that is why it reacts with the 5 acetic anhydride to form penta-O acetyl derivative. So from this, the presence of 5 hydroxyl group have been confirmed. Okay. Next. Now let us talk about the oxidation to carboxylic acid. See, on oxidation in presence of nitric acid, we are able to get, that is, gluconic acid. It means that CHO becomes a COOH. And then on further oxidation, it gives, that is, this CH2OH is also converted into COOH. So it forms a dicarboxylic acid. Here it is saccharic acid. So we know the formula of saccharic acid, that is COOH, CHOOH 4 times and COOH. So saccharic acid is a dicarboxylic acid. So based on these studies, we were able to arrive at, and we know the anomeric forms of these carboxylic acid. For example, here we have got COOH, CHOH, 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 CH2OH. Another form COOH, CHOH, 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 CHOH. This is the, from this it's clear that we are able to get a dicarboxylic acid. Okay, so this is a monocarboxylic acid, CH2OH, and this is dicarboxylic acid. What do you call the monocarboxylic acid? Gluconic acid. What do you call the dicarboxylic acid? Saccharic acid. So the structures are confirmed from these two acids, and that is why we have proposed the structure of glucose, that is CHO, CHOH and CHOH, and you can count from here. This is 1, this is 2, this is 3, 4th carbon, 5th carbon, 6th carbon. So from down, that is 1, 2, 3, 4th carbon, where the hydroxyl group is present on the left side. Okay. So this is the way we can elucidate the structure of glucose. Are you able to understand this? Right.